The other thing this brings up is pH. There's also something called pOH, KW, and pKw. Now, since we've said that KW is always going to be 1 times 10 to the negative 14, when we do that business of saying minus logarithm of KW, okay, the logarithm of it was negative 14. The negatives are going to cancel, so pKw is always 14. It turns out that pKw is always going to be pH plus pOH because those are the things it was made out of. So pH and pOH will always add to 14, the same way that the concentration of hydrogen ions times the concentration of hydroxide ions was going to be 1 times 10 to the negative 14. And this is just your same definition, only with OHs instead of H's. So instead of pH, it's pOH, negative logarithm of the concentration of hydroxide. That sets up a nice little square of things so that if you know any one of these, you can calculate all of the others. pH is tied together with pOH by our pH plus pOH equals 14. So you can get from one to the other depending on which way you're going by using these formulas. If you have pH, since there's a definition for pH of this, you could undo this equation, use your algebra to say that, oh, the concentration has to be 10 raised to the negative pH. Oh, all right. So we can switch between these. The same way we can do it over here. It's a little less familiar, but if you do it a couple times, it will get to be just as familiar as doing it with pH. And then these two are connected together by the KW that we had come up with before. So if you know any one of these corners, you can find out all of the other three. Since we said that we could find out all of those other values if we had any one of the four, we have been given an example here where we know the pH, and it has been given to us as 11.70. We can very easily then find out what the pOH is simply by subtracting this number from 14. So there is your pOH. Now each of those can be used in order to find the concentration of these. Now you'll notice I've written it like this. That's the old style of writing it. Nowadays we use the hydronium ion in here instead because we are saying that as a Bronsted-Lowry acid, it has the ability to donate an H plus rather than these H pluses are just running around loose and rampant, okay? So these are exactly the same thing. You might find this in an older book, and you should always find this in newer editions. So how do I find this? Well, we have to turn around and think about what the pH equation was. It's minus the log of the concentration. I want to know this. So I'm just going to go ahead and change the sign. And then I'm going to do this. Oh gosh. Cut. Did it wrong. It's a 10. Never mind. It's log base 10. Those will cancel so that you will have concentration of ammonium ion. And over here, you're going to go 10 to the negative. Oh, what was the pH again? 11.70. You use your calculator on that, and you're going to find out that it gives you a number of 1.995 times 10 to the negative 12. Here's where I have to warn you about significant figures when it comes to doing this type of thing. It turns out that when you're doing significant figures for this, this has so much more to do with this. This is where these come from. So it would be inaccurate to go ahead and use 4 sig figs here because I really only have 2 sig figs up here. At best, I should use 3 down here. That's being generous. So we would end up thinking that this should be the answer. Now at this point, we can either do the same process for this, saying 10 to the negative pOH is going to be equal to the concentration of OH minus. I've cut out all of the explanation and I've just done it, okay? Or we could say, hey, guess what? We know that the hydronium ion concentration times the hydroxide ion concentration should be equal to 1.0 times 10 to the negative 14. You're allowed to use more zeros here for more sig figs, but we're sticking down here to this. We would end up saying then that the hydroxide ion concentration should end up being 5.0 or possibly 00 times 10 to the negative third. And both of these are concentrations, so you should expect to say molar so that you know the units of the concentration.